computer. So we're gonna start the class here now. So there you go. So we just stop at so make sure you know how to find the mean, the median, the mode, the mid-range for your using your StatCrunch. For if your StatCrunch came out to be multi-model, so this is the stuff that you need to do. So for multi-model, make sure you go under the highlight here. So this is for if you have more than one modes. So follow this highlights. So we're gonna talk about how to find the mean. So that's today's class here. So there are two types of mean that you actually need to find. That is based on if I give you a frequency distribution and if the mean is weighted mean. Weighted mean in this case, like GPA, how if you want to calculate GPA, that will be considered weighted mean. So what do you mean by how to find mean of frequency distribution is like if I give you a frequency distribution like this, we can calculate the mean here without knowing the raw data. That means without knowing all this data, we can still find the mean. And the last thing we're going to concentrate here is how we find the GPA for calculate GPA in this case. And GPA is considered part of the mean. So let's talk about the mean, the mean for the distribution. So in order for us to find this sample mean here, is you take the sum of the frequency and you multiply that with your midpoints. So in order for you to figure out the sample mean for frequency distribution, you need to know how to find your midpoint, and then you divide this with the sum of your frequency. So this is a formula, and again, you do not need to know this formula because when you use your StatCrunch does not. They just input it into your StatCrunch, and they will give you the. If you click on the select, I'll show you this right over here, and then you will be able to find this frequency, the mean for the frequency distribution without knowing this formula. In order for you to find the weighted mean of a GPA, if you want to find a GPA, it's the same thing. The sample mean in this case is the sum of the grade times your credit hours. So and then divided by the sum of your credit hours. So this is how you figure out your weighted mean in this case. Again, you do not need to memorize this formula, these two formulas, because StatCrunch will do it for you. So when I say grade in this case, this grade means you have to translate your grade A, B, C, D, F into numbers. We call it the weight. So A in this case corresponds to 4 points. B in this case is 3, C in this case is 2, D in this case is 1. And then if you get an F in the class, you get a 0. So this is the grade when I say the grade here. And then the credit hours depends on your class. Like this class is 3 credit hours, so it depends on how many credit hours. So you do need to multiply it, and then you need to add it up. Same thing with your frequency distribution that you have here. But however, if you use your StatCrunch, what you need to do in your StatCrunch is you go to under stats, under summary stats, under group or bin data. I will show you how to do that. And then when you open up the StatCrunch, you got all this like an Excel, you got all these little columns. So on the first column, you put down your bin, okay? So in the first column, you make sure you put down your number, like your midpoint or your grade. For the next column, you do the frequency or the credit hours. So make sure that this is usually done in column number 1. If you open up your StatCrunch, and then this is done in column number 2. So you can you can look, if you look at your, yep, if you, so you guys will have to, if you are waiting for anything, please have your StatCrunch running background. Some of you was like, how do I do split screen? So make sure you cut this Zoom video into half of the screen, and then your StatCrunch or your MyStatLab into the other half, so you can, you know, follow along what I'm trying to teach you guys here. It's not that difficult once you practice a little bit on it. So don't forget, do you guys remember how you find your midpoint? Anyone still remember how to find your midpoint? Anyone? Midpoint? You did this in my homework.
Isn't that like the min, excuse me, the min plus the max divided by 2?
Yep. So make sure make sure this is not in StatCrunch, you do need to find the midpoint first before you enter it to your column, the first column. Yes, you take the mean and the max of the class and then divide it by 2. Okay, so this is very important. Next thing is talking about here is how do we know if you want to figure out you got 2 numbers, you know, how do these 2 numbers actually big difference or no little difference? Is in order for you to figure out are there a huge difference or small difference, is you have to find the percent change, percent difference here. How do you find the percent difference? Is you take the difference of the amount over by its original and then times it 100%. If this is more than 5%, then this is considered not close to it. Okay. Otherwise, if you find out this percentage is less than 5%, then it's considered close. What do I mean by this note here? For example, is that you want to figure out, this is an example. Let's say you have, let's say you find this mean, we call it as a computed mean. And this computed mean, let's say you figure out is 58.3, let's say. And then you find out the then they also will provide you an actual mean. So let's say the actual mean is 56 point, let's say 55.6. Okay, so the question is this close? Okay, so this is a question asking. So you found, you calculate the computed mean is 58.3, and you find out that the actual mean is 55.6. So the question is asking, is this 2 considered close or not? So what you need to do here is first you have to find the difference of the amount. So difference means you subtract them. So you subtract 58.3 from 55.6. So you minus these 2 numbers. What was that? Be 58.3 take away 55.6. So it's 2.7. So the difference here is 2.7. So in order for us to find the percent difference, what do you do here is you take the difference amount, which is 2.7, that you subtract these 2, over by the original. Original in this case is your actual mean. So the actual mean in this case is 55.6. And you multiply this by 100%. So we want to figure out what percent is this. If this percent is less than or equal to 5%, then your answer will be yes, they are close. If this percent is more than 5%, then the answer will be no. So I got 2.7, the difference here. So I'm gonna divide this by the actual 55.6 times 100%. So this came out to be 4.86%. Okay, sorry, this came out to be 4.86. Where's my? It came out to be 4.86%. 4.86%. So since this 4.86% is less than 5%, so the answer is this close? Your answer in this case will be yes. Okay, so when you do my online homework in this section 3.1 and 3.2, if they ask you, these 2 numbers are very close to each other, and how do you figure out is you do what we call as this percent change here, where you take the difference between these 2 numbers over by the actual and times 100%. And if that number is less than 5%, then the answer is yes, they are close. Otherwise, they are not close. Okay, so this is something that you will see in the next example coming. Okay. So let's talk about number 3. So question number 3 is asking us to find the mean given us the frequency distribution. And then after that, they want you to compare if the mean that you calculate in this frequency distribution, and they want you to compare this with the actual mean, and they want to see are they close or not. So the question is asking, is this close? Like the same thing that I just asked you about that. So so in order for us to figure out to calculate this mean, you need to find the midpoint first. Do you guys still remember how you find the midpoint again, like the first class? You have to add them and divide by 2, right?
Yep.
So what is a midpoint for the first class here? So you add 60 and 69 and divide by 2, you will get what?
64.5.
64.5. And then you do the same thing, 70 plus 79 divided by 2, you will get
74.5.
75. So you know that this is all is having an increments of how many? Can you guess what is the class width here?
10.
10. Yep, the class width is 10 because the difference between 60 and 70 is 10. So what you do is you just need to keep on adding 10, right? So this is 84.5. This is 94.5. So this is 104.5, and then this is 114.5. So this first you need to do is you have to figure out your midpoint first. Okay. So and then the next thing you need to do is to translate.
Excuse me.
Yep.
How about the last one, the last number?
Oh, sorry. Thank you for the last number. 124.5. Yep. Totally forget about that one. Yep. Sorry. So once you get your midpoint, then you transfer this into StatCrunch. So you put this under column 1. Okay. And then you put all the frequency in column 2. So what you need to do here is, so the midpoint that we have is my StatCrunch. Okay. So make sure you have your StatCrunch here. So in the first column is your midpoint. So you do need to transfer into here. So the midpoint, I'm gonna minimize this so you guys can see. So the midpoint, the first midpoint we have is 64.5. Oh, sorry, 64.5, 74.5. So you have to literally type it out. 94.5, 104.5, 114.5, and 124.5. So make sure you enter. And then the second one is your frequency. Okay. So the frequency is all these numbers. So you just copy and paste 12, 14, 11, 1, 1, 0, 1. So make sure you enter on the last one so that your cell goes up. So this is what you need to enter here. And then what you need to do here is you go to the stats, the one I highlight in yellow here. Stats, go to summary stats, and then go to the group bin data. So this is the one that you need to go if you need to find the mean or the GPA of a frequency distribution. So you put here. Make sure your bin is your midpoint. So in here, you click underneath here, there is a midpoint. And then the counts is in frequency. So this is what you need to do for to do this. So make sure you type this in and then go to group to stat, summary stat, group bin data, the last one here. Make sure the bins is midpoint and the counts is frequency, and then you hit compute. What you see is the first number, 76.75. That is your mean. That is what we call as your computed mean. So in order for us to find this computed mean, so your computed mean in this case is 76.75. Okay, so this is the rest you can don't worry about looking at the rest. We just only concentrate on the mean here. So we what is the units here? Since this is talking about pulse rate. So the units in this case is beats per minute, BPM. Okay, so this is a computed mean. And then the question provides us the actual mean, which is 76.3. Okay, so this is the actual mean that is given in the question here. So now my question to you is, are these close? Are these two numbers close? Is these two numbers close? So
Yes.
if you, yes. So sometimes you do not need to calculate this. You just, oh yeah, 76.75. So the answer is yes. These are close, right? But if you, because this is very, I mean, if you look at this, the difference are very, very small. But if you really, really want to, calculate this, then you do what I just showed you here, is you find the difference, and then you find the percent difference, and then see if they are less than or more than 5%. So if, let's say if you're doing homework and the numbers are not as close as this, they are a little bit apart. So if you really want to calculate this, so what you need to do first is you have to find the difference first. So the difference between 76.75 and 76.3. So if you take up your calculator, you can actually, calculate this. And if you start 76.75 subtract by 76.3, so the difference is only 0.45. And then in order for you to find the percent, you take the percent of the difference here, 0.45, over by its actual 76.3, and then multiply it by 100%. So we want to figure out what percent is this. So let's divide this with the actual 76.3, and then you multiply this by 100%. So this is actually is only 0.59%, which in this case is less than 5%. So that's why your answer is yes, they are close in this case. Okay, so they are close in this case. Sometimes you can, like this like these numbers, you do not need to really calculate all this work here. You can tell, like eyeballing it. It's like, yes, these two are close. It is true, right? So you can eyeball this, and you do not need to do all this work. You still can figure out. But sometimes, I don't know your homework, but sometimes when you do your homework, the numbers is not as close as this. So then you have to perform all this, all this calculation. You guys with me here? Questions with this? How do you find the mean for the frequency distribution? Another way to do this is to find the GPA. So this is another question they do. It's very similar. The student earns the grade CBAAA for this course, correspond to the credit hours 34232. So that means the students get a C on a 3 credit class, a B on a 4 credit class, and A's on the 232 credit class. And this is fixed. You cannot change this. The A is 4, B is 3, C is 2, D is 1, and F is 0. You need to compute the GPA. So this is very similar to what you did over here. So instead of midpoint, you need to change this midpoint to become grades. So you need to have grades, and you need to have, and you need to have credit hours. Okay. So what you do here is the grades that we have is a C. C in this case is a 2 credit. Okay. And we also have a B. A B in this case is a 3 credits. An A is a 4, and A is a 4, and an A is a 4. So when you type this in the StatCrunch, you don't type the CBAAA, you type in the 2, 3, 4s. And the credit hours correspond to this 2, 3, 4, 4 is 3 credits, 4 credits, 2 credits, 3 credits, and 2 credits. So this is the the credit hours correspond to it. So again, in the StatCrunch, you type this in column 1. And you type this in column 2. So it's very similar to what you did on the midpoint here. So make sure you know the grades is 1 and the credit hours is 2. So when you go to your StatCrunch, we don't want this, so we will change this. When you go down there, you can delete the whole thing. So you know, so it's quicker. So this one will be great. And this one will be credit hours. I just put hours to short form it. So do not put CB. So CBAA, put 2, 3, 4, 4, 4. So put the grades in here. And then the credit hours in this case is 3, 4, 2, 3, 2. 3, 4, 2, 3, 2. Should I type correctly? So make sure you enter them correctly and make sure you enter them correspond to the grade and credit hours. You cannot put the 2, you got a C for 4 credits. You cannot do that. So make sure you put them in the same order. And then as usual, you go back to stats, you go to summary stats, and you go to the group bin data. So this is the same procedure for question 3 and question 4. And the bins is the grade, the first one, and the counts is in hours.
Excuse me, doctor.
Mm-hmm.
Why are we using the group bin?
When?
Why are we using just a group bin?
What in the StatCrunch?
Yeah, why? Why just group bin? Because
this is the way that we do in this case.
Okay.
Yeah. This is different from the one that you learned on Wednesday.
Okay, thank you.
Yeah, this is special case because this is where it's in a table form.
Okay, thank you.
Mm-hmm. And you hit compute, and the mean is the one that we're looking for here. Okay, so make sure that the last time when you do is just that they give you raw data, so you just go to the StatCrunch, you go to the stats, and then you go to summary stats and then columns, right? This is what you do last time because they give you raw data. But once they give you a table like this, then you need to use the group bin type.
Okay, thank you.
Mm-hmm. So your GPA in this case will be your mean. So if this question wants you to round in 2 decimal place, so this will be 3.29. This will be 3.29. So the GPA in this case will be 3.29 in 2 decimal place. So again, if I didn't ask for how many decimal place, then it's up to you how many decimal place you want to put. But since this question wants 2, so we need 2. And the question does ask us that in order for us to make it to the dean's list, I'm going to mute you, Lawrence. You need to have a GPA of 3.3 or higher. So since the GPA you get here is only 3.29, which is a little bit shy on 3.3. So in this case, the student did not make it to the dean's list. So so in this case, because his or her score is just a little bit shy on 3.3. Okay, so because the GPA you get here is 3.29. So this is how you calculate your GPA for your classes. So if you doesn't know how to calculate GPA, now you learn how to calculate GPA. So it's actually is considered mean in this case. So let's say this is what you have for last semester in spring. So let's say this semester you done. So what they do is you continue putting more. So if you want to find your GPA for like whole 2 years of school, you will have a lot of grades, a lot of credit hours. So that means when you want to find it, then you will have to keep on putting all the grades that you have for spring semester, fall semester, and the corresponding credit hours. So you have a very long, so when you finish your degree, you have probably like pretty long, a lot of pretty long lists And you still use the same thing. You just use back the same, the group mean in this case to figure out your GPA. And that's how you find the GPA in this case, okay, for your class. And it's fixed. All these numbers are fixed, A, B, C, D. So this is how you, again, this is how you find this. You do not need to memorize this. So make sure you know how to, you don't memorize the formula. So make sure you know how to put down where to go, which is we use group B in this case. Okay. So this homework and 2.3 homework will be due on Wednesday. So make sure you guys, this is the 15th, right? So we do meet on Wednesday in school. So if you have any questions, we can talk about it. So 3.1 and 2.3 is due on Wednesday. So this is what we talk about measure of center. So does anyone have any questions here before we move on to 3.2? Measures of variation.
I have a question. For the online homework, you know how there is multiple modes. I know you told us last time that we can write down there are 3 modes or however number of modes there are, and then just write down 0, 0, 1, 1, 2, 2. But the online one actually wanted the one that shows up more than the other one.
Then you have to go through these steps. If you have a multi-model, in StatCrunch, you have to go to stat, tables, and frequency. This is what you need to do, Soli.
Okay.
Do you know what question is that?
Yeah. That's what I said.
Yep, you, again, class, you need to send me questions. I mean, I do not know what questions is that. So you do need to send me the questions, then I can look at it and then I tell you what's going on.
I mean, I know I've already sent it to you. I just wanted to speak to you in person about it because I don't do well with emails. What is it?
Oh, when you have mode, we just talk about the greatest frequency.
Yeah, because I was writing down because there were like 2 or 3 multiple modes that shows up like frequently, and I was writing down 2 or 3 of them, but it wasn't taking it until I viewed the example, and then they wanted you to write down the greatest one, like whichever number that shows up more than the other.
Okay, I got your emails. Yes.
So
if I Soli, if I give you 1, 2, if I give you this data set 1, 1, 2, 2, 3, 3, 3, 4, 4, 4, what is your mode in this case?
So it would be 3 and 4, right?
Yes.
But the online homework does not want you to write down 2 numbers.
Yes.
Okay.
I do not. If I put another 4, then what is your mode in this case?
Okay, so that's when I was confused because it actually want 4 instead of 3 or 1, 2, 3, 4.
Yeah, yes, that will be your mode in this case. You got 1.
Because I mean, I was going by what you told us in class, and I was putting in like 1, 2, 3.
Because you asked me the question, is this important? No, this is not important because these are just only come up twice or 3 times. This has come up 4 times. This is important.
That was interesting.
Did you put like a comma between the numbers? Like
yeah,
if it was
you need to put comma in between your numbers.
You have to put you have to put commas.
Okay, I found that was my mistake.
So if you don't put a comma, then it read 34, not 3 and 4. 2 different numbers. Yep. Okay. Next we're going to talk about here is variation. So the variation, we got 4 types. One is called a range. One is called a standard deviation. The third one is called a variance. And the last one is called the interquartile range, which is called as IQ bar. Okay, so so as you know that variation is talking about how spread the data is. Center means the middle of the data. Variation is how spread is it. So there are 4 ways to measure it. So one of them is called range. This is the most common way. The range in this case is the difference between maximum and minimum. So a lot of students tell me, oh, the range is from 50 to 80. Do not give me that. So that is considered wrong. Okay, so let's say you look at the range, the smallest is, the minimum is 50 and the highest, the maximum is 80. Then a lot of students tell me the range is 50 to 80. This is wrong. Okay, don't do this. So the correct way to do this is you find the difference. So what's the difference between 50 and 80? What's the difference between 50 and
30.
30? So in this case, this is correct. So make sure that don't do this in my test. When I ask you for range, I got students give me, oh, the range is, you take the minimum and the 50 to 80. That is wrong. You have to actually subtract that. Okay, so 30 is the correct answer. And since we use a maximum and minimum, so it will be very sensitive to outliers. So your range is sensitive to outliers. The reason why is because we only concentrate on the minimum maximum, and usually outliers is found in the minimum maximum, in the low end or the high end. So that's the reason why that range is not a good choice if you have outliers. Okay. So what is better choice than range? Standard.
I'm sorry, Doc. My laptop went off. Could you please go over the range again?
You had to watch it again, Lawrence. I cannot repeat.
Okay.
Range is the difference between maximum and minimum.
Oh, okay. That's good. That sounds good. Thank you.
It's max minus minimum.
Okay, thank you.
Standard deviation. Standard deviation is something new to everyone because you probably have not heard this before. The shortcut for standard deviation is SD, or if you want, you just write S. So add the letter S, small letter S, is considered standard deviation. What is standard deviation? This is very important. Standard deviation in this case is how much the data values that deviate from the means. Deviate means differ. Okay, how much is it differ from the mean? That means how much is it change from the mean. So what is going on with this standard deviation is we look at the difference between your data value and the mean. Example in this case is let's say we have a test. I'm giving you a test, and let's say I can find the mean, right? So I take all the numbers. So I score like someone have 62 and 73 and 85 and 82 and 86 and 93. Let's say these are the test score. We can find the mean very easily, right? We just add these up and then divide it by 6. So I'm gonna use my calculator, it's quicker that way. 62, 73, 85, 82, 86, and 93. And then I divide this by 6. Divide by 6. Let's change this 93 to 92 because it will be less. I'm making it nicer so that instead of decimals. So I'm not going to do 93. So it's 92. So it's 480 divided by 6. I just make this nice. So it's 80. So the mean in this case is 80, just purposely for showing you what standard deviation means. So what we do here with standard deviation is we take the difference between the data and the mean. So since this 62 is below the mean, so if you take the difference between this is actually negative 18. So when you find the difference, if you get yourself a negative, means that your test score is below the mean. This is going to be -7. This is +5. So when you have positive, means you are above the mean. This will be positive 2. This will be positive 6. And this is positive 12. So this is how we find your standard deviation, is figure out how much is it different from the mean compared to score. Now, if you add all this the difference, negative 18, negative 7, 5, 2, 6, 2, what do you get when you add all this up? You take like, I'm going to do 12 plus 6 plus 2 plus 5. I add all this up. And then I minus 7. And then I minus 18. What do I get? I get 0. So no matter what you do, if you find the difference between the mean and the test score, and then if you add all these numbers, the positive and the negative, you always get a sum of 0, always. So does that mean that your standard deviation is 0 here? No, your standard deviation is not 0 in this case. So the reason why is because this negative will counter with the positive. They kind of like, cancel each other off. So in order for us to get not to have this issue, because the negative will, balance up with the positive. So what do we do in this case is we square it. We take the number and square. And the reason why is because once you square a number, the negative will become positive and the positive will become still positive. So when you square this, all the negative number is no longer negative anymore. So what happened is that this is what happens when you do standard deviation is you take the difference of it, the number with the mean, and then you square them. So what is 18 square? I think is 324. So this number is no longer negative because you square it. This will be 49. This will be 25. 5 squared is 25. 2 squared is 4. 6 is 36. And then 12 is 144. 12 times 12 is 144. So when you sum this up, this number won't add up to be 0 because they're all positive numbers now. So this number will be 324 plus 49 plus 25 plus 4 plus 36 plus 144. So this sum came up to be 582. So so this is the main part of standard deviation in this case is we square something else. And as you know that we can always counter this. So what is the opposite of square? So we can opposite, like addition, the opposite is subtraction, right? Multiply, the opposite is divide. So what is the opposite of squaring? We take the square root of it. So so what we do in this case is we take the square root of this number. But before we take a square root of this number, we have to divide by the sample size, the size minus 1. This is a real formula in this case. So that means we got 6 numbers here. So we will divide this by 5 first. So we take 582 divided by 5, and you take the square root of it. And this value that you figure out is called the standard deviation. So 582 divided by 5, and then you take the square root of this number is 10.8. So the standard deviation in this case is around 10.8. Now, you do not need to know this because the StatCrunch will do this work for you like this. So the formula to find the standard deviation, this is a formula, is the square root of the sum of x minus x bars square, because you need to square it, divided by n minus 1. So this is a very easy formula. This is how you find your standard deviation. One of the formula is this formula, which I just did over here, the long way. As you know that if you have StatCrunch, you do not need to do it. So if you have a StatCrunch, what you need to do is you just need to enter your test score in here, your 6 test score, and then you do what you learned in Wednesday class. You go to your column and find the mean. So this is the fastest way to do it. So yeah, so do not when you look at my the videos that I sent it to you, they use the old way. So when I say old way, means they use this way. They the one I showed you, the long way, the calculator way, a lot of work, minusing and then squaring and then adding up. So the best way for us is just use your StatCrunch and just type. If you do your homework, you can actually import all those data into StatCrunch. I'll show to you how. Just a little box in the corner and just import all to StatCrunch. And then what you do is you hit stats, you hit summary stats and column. Remember this one we did on last Wednesday to find the mean and the median. This is the same thing. You just click on here and make sure you highlight variable 1, which is this context here, and you hit compute. And you find out that this is your standard deviation, which is the same as what we just calculate in here, 10.788, 10 points. Yep. So it's very close. It's exactly the same. So again, class, I do not want you guys to learn it this way. So do not learn this way. In the test, I want you to do it the StatCrunch way, which is way easier than that. So in other words, you do not need to memorize this form. Okay. So but there are a few things you need to know about this standard deviation. One, like mean, it has population mean and sample mean. Standard deviation also has 2 types. One is a sample standard deviation, which is denoted by the letter S. The standard deviation for the population one is denoted by sigma. I cannot type this because it's not in the keyboard. So sigma will look something like this. This is sigma. Okay, this is sigma, which is also a Greek letter. This is for the population standard deviation. So this symbol should be in here. And I cannot type it out because my keyboard doesn't have the symbol sigma here. It looks like a number 6, but it looked written down like flat instead of so it's like like this, looks like a number 6. So this is a population standard deviation. Okay. There are some properties. The first property is the standard deviation shows how much is it deviate from the mean. So we use mean, not median, not mode, not mid-range. So we standard deviations always use the mean. Standard deviations can be only measured.
Quick question. What was the direction for the StatCrunch again for this one?
It's the same as you find mean and the median and mode.
Okay.
So you just go to the stats, summary stat, and column. The same as you find mean and median and mode, what you did on Wednesday. So standard deviation can only be positive. The reason why it can only be positive is because of the square root symbol. You guys know that when you take a square root, this number always has to be positive. You cannot have a negative inside the square root because if you put a square of a negative number, this is complex, it's I. So what I want to point out to you here is if you tell me your standard deviation is -3 or -8.5, I will look at you as like, no, that's wrong, because standard deviations can only be in positive numbers. Standard deviation can be 0. What does it mean by 0 here is that means all your data values has the same number. Okay, so I cannot be negative. So what I mean by if your standard deviation is 0, it means that if you have all your data sets, so if you have 10, let's say this is your test score, and let's say everyone in the test, everyone who did the test, everyone scored 10. Everyone scored 10. What will be the mean here? if everyone scored 10? If everyone in your class scored 10, so the mean will be what? Will be 10. What is the difference between these scores with the mean?
0.
0. This 0. Everything will be 0. What happens if I square them and do all the square root? I will still get what?
0.
0. So that means that your standard deviation can be 0 if what? All your data is the same. So if you got all same number 10, 10, 10, 10, or 20, 20, 20, 20, then the standard deviation is 0. Okay, so it's very rare to get it. How can you? What do you think if everyone take my test, everyone get the same test score, or 80, 80, 80, 80, all of you guys score 80? That's really rare, right? So so this is, and if that happens, then the solution is 0 in this case. Since it is depends on mean, so it will be affected by outliers. So standard deviation will be affected by outliers. Standard deviation will also use the same units, means that if this is inches, let's say, then your mean will be inches, your standard deviation also will be inches. So this is the 4th property. The last property, you can skip it. We do not need to worry about the last one, the bias estimator. So you can skip the last the 5th one. We're not going to learn in this class, so don't worry about that. So these are the 4 properties of standard deviation, which is very important. Okay. The most important is make sure you know the standard deviation cannot be negative. This is the most important one. It never be negative. Okay. So usually in the test, I give you like a trick question. I give you, oh, this standard deviation is negative 10.8. What's going on? And you will say, it cannot be. Okay. There's no way it can become negative. So that is the standard deviation. What is the important, or what do we use it? Okay. So for standard deviation, we use to find outliers. So one of the most important stuff that we learn, that you will learn here, is standard deviation is used to find outliers. How do you find your outliers? Is you take the mean plus minus 2 times the standard deviation. Okay, so so what happened is that you will get a plus. Plus means it's higher, so you will get one end, you will get mean plus 2 times your standard deviation, and then the other end you will get mean minus 2 times the standard deviation. So you will get like each range of it. So let's say you got one that is start from here. This is your mean minus, and one is mean plus. So you got 2 numbers, and any numbers that fall in the middle is not significant. So when I say it's not significant, means that it is no outliers. Okay, so this is how we figure out outliers. So if you find, you take the mean plus minus 2 times solution. If your number fall in between these 2 numbers, we call it no significance or no outliers. But if your number falls outside this on the lower end, we call this as significantly low. And if your number falls on the other side, it's called significantly high. Okay, and so no matter you're significantly low or significantly high, this is considered outliers. Okay, so they are considered outliers in this case. So if your number 4 is outside these 2 numbers, is considered outliers. So for example, is we just did an example here. So we have a test here, right? So these are the test score that we did, and we find out that your standard deviation here is 10.8. And the mean is 80. Okay, the mean is 80. And the standard deviation is 10.8. So what we do here is we figure out what is the low end and the high end. And how do we figure out the low end? You take the mean, which is 80, minus 2 times 10.8. Take out your calculator, class, and I want you, or cell phones. This is easy. So the amount, and then you're going to find this is a low, and the high in this case, we're going to take class 80 plus 2 times 10.8. Anyone has a calculator? This is very easy calculation. What is that? 80 minus 2. Yep.
The higher end is 101.6.
101.6. So this is
Yeah.
101.6. How about the other end, the lower end? It will be 58.4, right? So this is your Lawrence. This will be your score here. So if your test score fall between 58.4 and 101.6, then it's considered no significant. No significant means it's not an outlier. If your test score fall below 58.4, then we call this as a significantly low. And if you fall above 101.6, this is significantly high. That means these are outliers. So if you fall outside this range, it's outliers. And let's take a look at the test score that we have here. Do we have any outliers in this test score? Do you have any outliers here? This number falls inside or outside this range?
Inside.
There are 4. 62 is inside, 73 inside, 92 is everything inside. So do we have any outliers?
No.
No. Yep. There's no outliers. So the only cases that is outliers is when they fall outside those ranges. So make sure, so far I didn't call you guys to memorize any formula yet, right? So guess what? This will be your first formula to memorize for my test, is this formula. So please memorize this formula. Oh, I think I told you guys you got allowed to use one piece of paper, right? Front page for your test.
Yeah.
So, yep. This will be the one that right now, this will be the first formula that I really want you to write on that piece of paper. And don't forget, this is called range of rule of thumb. It's a long name, and you will see that in your homework. You will see that in your test. I will use this word. Use the range of rule of thumb to find the significantly low, significantly high, so on and so on. So this is where you will use this formula, the one I show it to you here, the mean plus minus 2 times the standard deviation, which you need to memorize. So this is what we call. Make sure you know this. You need to memorize this. Very important. Short, because this is range of rule of thumb is too long, so you can shortcut this to ROT.
Did you get it? How's everything? Let me know if everything goes well.
Suli, are you okay? We're going to give you an example for this. So this question, number 5, is where they want you to refer to an OSCAR data set. So once I want you to refer to OSCAR data set means you have to go to the data set from StatCrunch, and it's under OSCAR. And you want to figure out the ages of the best actor. So how do we do that is you go to StatCrunch. Make sure you go back to the original StatCrunch. No, you go to back to your main stat lab here. the data set from the textbook. So you click on this one and you will use Oscar, like Academy Awards. So there should be an Oscar. There you go, Oscar winner age right here. So click on it. They will import all those numbers in there. So these are all been import for you. So you do not need to type it in. We are doing actors in this case. This is the one that we need to. And as you know that this question, if you read this question, is asking us, is an actor who was 25 years old, is he a significantly low or significantly high? So what do we do here is we will figure out what is considered significantly low and what is considered significantly high. So you need to figure out what is the mean here, and you need to figure out what is the standard deviation here. And how do we do that is you go to your summary stat columns. Remember how you find your mean, median, mode last Wednesday? This is the same thing. So you click on here, but make sure you pick select the correct columns, because we are talking about actors, not actresses. So you make sure you select actors and then you hit compute. And you will, the question, your StatCrunch will give you the mean and the standard deviation. So by looking at the actors, the mean is 44.12. So that means so you do not need to, it's not a lot of work here. So so the mean in this case is given to us by 44.12. And the standard deviation, make sure you use standard deviation, not standard error. There are two different things. Mean is 44.1213 actually, if I run 2 decimal place. Standard deviation is 8.93. Okay, 8.93, not the standard error. So the formula that I want you guys to know is mean plus minus 2 times the standard deviation. So I want you guys to take out your calculator based on the mean and the solution given in this example. What is the low and what is the high in this case? Go ahead and use your calculator and do that. What is your low and what is your high? That means you take the mean, which is 44.13 minus 2 times 8.93, that will be the low. And you do the same thing but add. So 44.13 adds 2 times the standard deviation. Take out your calculator and start. This is easy. This is not tough. Anyone calculate the low and the high?
The lowest one is 26.27.
I'm sorry, the low is what?
26.27.
Okay.
And the highest is 61.99.
Okay, so this is the low and this is high. So again, anything that falls in the middle is considered no significant. Anything falls on the left side is low. Anything falls on the outside is high. So what is the question give us? What number the question provide us? The question is asking for how old is this actor?
25 years old.
25 years old, yes. So is this 25 years old considered significantly low or significantly high?
Low.
Yep. So the answer in this case is the 25 years is significantly low in this case because it is right here, right? It's before 26.27. So this is how we figure out. In our world, we say this is an outlier. So if you are 25 years old and won an Oscar during that time, you will consider the youngest person who won it, who win the Oscar. Okay, so that is the meaning of so this is what we do for this.
So quick question, like, we're getting the the standard deviation and the mean off of StatCrunch, correct?
Yeah, yes.
Okay,
Yep, right over here. You have to go because the question, you have to go to StatCrunch and get it and calculate it actually.
and are you gonna give us direction on the exam sheets, like
No.
for each of us?
What kind of direction?
You know, like, whatever your numbers are, put it like, go to stat.
No,
column, this,
no,
that.
no,
No?
no, no.
Okay.
Again, I already told you, you're allowed one piece of paper, right?
Yeah.
You're allowed one piece of paper. And the thing is that if you practice this, you do 3-1, 3-2, 3-3, you'll be everything. If you practice this, you'll be doing this. You know what to do.
Okay.
So this is one of the most important properties, or one of the most important usage of standard deviation is to find outliers. And this is how we figure it out. If the standard deviation is not given to us, then we use this formula. Is you take the range divided by 4. But I would suggest don't use this. This is just approximation. So this is just approximation. So so if the question asking you what is the standard deviation and they don't give you any data, they don't give you anything, they just give you the mean and max, then you will use this approximation. Again, don't do this in your test, because in a test I usually don't want you to do it. So I think only like one homework questions they give you the max and the mean. So example is like, oh, the maximum of this is 80 and the minimum in this case is, let's say, 20. So what is the approximation of standard deviation? So how do we figure the standard deviation here? Approximately is to take the range divided by 4. So the range, remember, range is the difference between the max and the mean. So what's the difference between 80 and 20? 60, and then you divide 60, and then you divide this by 4. What is 60 divided by 4?
15.
15. So that will be the standard deviation. Again, the method I'm showing you right now using the approximation here is not good. This is not a real one. So usually we don't use that. But if I think only one question is in your homework asking you that, that's only when they give you the max and mean. They don't. If you don't give you all the raw data like this question, then yeah, you use estimation. Okay. Again, it's just estimation. It's not accurate. This is not accurate. So that's the reason why I do not want you guys to know this formula or skip it. So don't worry about that. Okay, it's not accurate at all. So this is the second one called standard deviation. The third type of variation, one is range, 2 is standard deviation. The third type of variation is called variance. What is the variance? The variance in this case is the square of the standard deviation. So if you take the standard deviation that you have here, and if you square it, you will get yourself a variance. So if you take this number and square it, mean multiply by itself, you will get yourself a variance. So the sample variance in this case is S squared. So how do we figure out the sample variance in this case? Is going to be is S squared, S to the power of 2. And the population variance in this case is a sigma squared. So don't forget, we got 2 types. One is from the sample, one is for the population. So let me save this one first before we. So last time we used this sigma for population standard deviation. So once you square it, then this is no longer called standard deviation. This is called variance. So this is called a population variance. Okay, and if you do the S squared, this is the sample variance. So variance is just taking your standard deviation and you square it. That's what it is. Okay. Since we just square your standard deviation, so your variance, the property of variance is very similar to the properties of standard deviation. Example is like outliers, it was affected by outliers. Okay, so same thing here, it is affected by outliers. Your variance is always measured as positive. If it's 0, then it is all the data values is the same. It cannot be negative, which is exactly the same as number 2. Standard deviation is positive. It can be 0. All the numbers are the same. Cannot be negative, right? These are the same thing as the standard deviation. And again, the last one we can skip it. We don't need to do it. Anything you see unbiased estimator, because this is the class that you don't use it, so don't worry about doing this. The only thing that is different, okay, this is not the same. The only thing that is different here is your units. Your units is no longer inches, it's gonna be square of the unit. So for example, is if your unit here is inches, then the where was that? Okay. Then your standard deviation will be inches, but for variance, your unit will be inches square. So that is the only difference between variance and standard deviation is the unit. The unit is just squaring the unit. Okay, so that's what we do. And your StatCrunch will give it to you, as you know that your StatCrunch is right over here on the variance. So if you guys want to be safe to have everything, what you do is you go to stat, you go to summary stats, you go to column. Okay, let's say you want to do actors like the one we did. This is a lot of statistics here, the mean, standard deviation. So what you do is you click on here and you do Control A. So Control A in your keyboard means Control All. So they will take all this and put it over there. And when you hit compute, you got everything. You got the mode, you got the mean, you got the standard deviation, you got the variance, you got the range, you got the median. So you got everything here. So your StatCrunch can do more. An example is, let's say in your homework, they want you to do actors and actress, both of them. So what you do is you go to stat, summary stats column. This time you select both. So you hit shift. So in order for you to select multiple columns, you just hit the shift button in your keyboard. So you click on it and then you hold on to the shift button and click on it. So you will see 2. And then I will do Control A here and compute. So now they give you 2. So this is for the actress and this is for the actress. So then you can, so you don't need to compute this twice, you know, so you can do like multiple columns for this case. So make sure you guys do practice this. It's not that difficult. It's just make sure you click on the correct columns and stuff like that to get you the mean and standard deviation. Anyone have any questions for me before we go to the last one?
Which one was inches? Just inches.
The standard deviation. So mostly everything is inches. Mean, range, they all have the same unit. The only unit that is not the same is variance, where you have to square your unit. So if you have a centimeter, then everything is centimeter. Mean is centimeter, everything is centimeter, except for variance is a centimeter square.
Okay.
The last one we're going to talk about here is interquartile range. Interquartile range is a very long name, so I short form it in IQR. Okay, so what is IQR? Interquartile range, IQR, is actually the difference between the third quartile, Q3, and the first quartile, Q1. Now, why we learning IQR is because IQR is resistant to outliers. So you can notice that all the variation that you learn in 3.2, the range is sensitive to outliers. The standard deviation is sensitive to outliers. The variance is also sensitive to outliers. So the only thing that is not sensitive to outliers is IQR. So and how do you find it? Is to take Q3 minus Q1. In your StatCrunch, you got Q3, third quartile, and you got Q1, the first quartile. So if you want to find the IQR for, let's say, the actress, what do you need to do is you just subtract them. So the actress in this case is, oh, it's right here, 12. Here we give it to you. So you don't need to subtract that. So if you take 41, take away 29, you get 12. Oh, actually, the IQR is right here. So this is the interquartile range. And the reason why we use interquartile range is because it's not affected by outliers. So, so what I want to point out to you here is, remember when you guys want to interpret the data, this is very important because when you interpret data, you do CBDO, right? The center, the variation, the distribution, and the outliers. So you have to pick the correct way to interpret data now. It's not simply just, oh, center. I can use mean, I can use median, I can use mode. Or variation, I can use variance, I can use this. No longer you cannot pick whatever you want. So in the test, if you want to use which one is which, you have to pay attention. This is very important. So if the data that you collect have outliers, I don't care, you got one or more. For the C, you have to report the mean. The center, C means the center. You have to report the mean. And the variation, you have to report the standard deviation. So, oh, no. Sorry. Has no, sorry. Has no. So, so if you find out that your data has no outliers, you have to report the mean and the standard deviation. Okay, this is very important. If the data has outliers, I'm going to scroll this one up a little bit so you can see it. Okay, then you will report median and IQR. So, so the first thing you guys need to do when you guys report, interpret the data is to figure out, do we have any outliers or not? If the data shows outliers, you have to report the median and IQR. If the data does not have any outliers, then you need to report the mean and standard deviation. So this is very, very important. So I put a little checkpoint here, a little, so this is very important, the one that I'm typing up here. So make sure you copy this in your notes or somewhere else, because that is what we will use a lot, especially 3.3 next Wednesday class. When you guys come Wednesday, we'll talk more about this. Okay. All right. Well, attendance. So make sure you guys go into your chat room and type present for your attendance, and we'll do some examples in this case. So make sure you guys know what to do. So this question 1 and 2, we're gonna do 1 and 2 here. Find the range, variance, IQR, standard deviation, including units for this case. So question 1 is asking us that these are the prices for the Las Vegas hotel that we did. So these are the same 10 or 8 data here. So you need to find the range, the variance, the IQR, the standard deviation, and then you need to figure out how useful is this variation to us. Okay, so let's take a look at so how do we do this is you need StatCrunch. So what you do is you need to, so usually because of you do not need to clean in all your StatCrunch, all the data here. So you use a new column. So what do I do is I put in var 3. So I just put this in var 3 because this is just a new where was that gone? So this is gonna be the strip. This is price for the hotel, right? And I just type 212.77 121, 104, 153, 264. What's the other one? 19 something. 195 and 244. 195 and 244. So make sure you the last one, I see some of you went like Wednesday. Don't do it like this. They won't count 244 as your data. So make sure you hit enter before you do all your work, all your stats work here. So this is how you enter the data, and you need to find the variance, range, IQR, all the goodies. So again, you go to stats, go to summary stats, go to column, and we go to price because that's the one that we are looking for. And then again, don't forget, go click down on the statistic, Control A. Hold on to the Control and A. You will get all of them there, and then you hit compute. Okay, compute. And you got all these goodies, so you can actually find everything. I think they got mean and max. Oh, they got range. So your range in this case is 187. So I'm gonna type this one out here. So you just need to type it out from the class. You need in the test, I got students copy this and paste this in here. I'm lazy, so I'm copying this and paste it over here. I want to point out to you that if you do that, you get 0 in your test, because if you are lazy, I'll be lazy too. So make sure you type it out, or make sure you write it out. So the range in this case is what? 187. And what is the unit in this case? Forget the units. They are in dollars. Standard deviation is the next one. Standard deviation is the one coming up. 68.0102. Again, the units is $sign. Again, I think I told you guys on Wednesday how many decimal place you do. 2, 3 decimal place is fine for me. The next one is variance. A short form I put is VAR. You can also do that in your test, which is this big number. Now, the only thing different is that your unit is not $sign. Your unit is a square dollar square, and it is 4626.21. 4626.21. Sometimes, because this is so weird, because some of you will ask me, what is dollar square? I will ask you back. I will tell you, I have no clue what is dollar square. I know dollars, but what is dollar square? So sometimes because of so confusing, we prefer just do not put any units on it. So for variance, it's up to you. If you want to put units, you put inches square, anything square. And sometimes if it's too confusing, like dollar square, then you don't put any units on it. Okay, so like dollar square and what else? Degrees Celsius square. No, so weird, right? I was like, what was that? I said, I do not know. And the last one is IQR. So you can also look at your data, your output here. Your IQR is right here, 115.5. Should put the dollar square, 115.5. So that will be your range, variance, IQR, and solution. And then the question is asking is how useful are these measure of variation for someone searching for a room? Actually, these are not useful at all. Actually, when you look for price of the hotel room, you don't look for the measure of variation. You don't look for the range. You don't look for this standard deviation or IQR. Usually, we are using the measure of center. So that means the mean, median, mode, like what we did on Wednesday. So I want to point out to you guys that not everything you calculate is useful or is important or is going to use. So some of them are not useful. Like this case, what you calculate here, the standard deviation and range, they are not useful when you want to look for hotel rooms. Usually you're looking for the mean or the median or the mode or mid range in this case. Okay, not this case. You guys all right?
Wait, so because when I'm looking for the mean, median, they're not useful.
Yeah,
correct?
yeah. Because these are not useful at all when you find hotel room, looking for hotel rooms. So we are using the measure of center that is more useful than these numbers. Question 2 is the same questions, but this time it's gonna be in quake, in your earthquake. And I think I told you guys on Wednesday, if you are lazy to write the units countless of time in your test, you just box it out and put unit like this. I will give, I mean, instead of writing or underline, I usually box it out because I don't have a box here. So either you box it out that unit, this is your unit. So Richter scale is your unit. So this is coming from your data file called earthquake. So we're gonna get a new earthquake. So this is your data file. So we go to earthquakes. And again, we got a lot of data here. So we are concentrate on magnitude. So magnitude is the one that we need to concentrate. So you go to stats, go to summary stats, go to column. Just click magnitude. We are not concentrating on that. And you do Control A. Control A means everything. And compute. So again, you got all this very nice informations. And you pick it up from here and put it over here. So can someone tell me what would be your range in this case? Anyone range?
3.7.
3.6, right? Right over there.
Yes.
Standard deviation?
0.65.
0.65. Okay, good. You can put it in 2 decimal places. I'm good. Variance? 0.42, right? Again, class, if you round in 2, make sure you round everything in 2. Don't round this 2 and then the other one 3 and then the other one 4. If you do everything the same, okay? And then IQI is the last one. 0.89, right? Which is right over here. You guys doing all right here? To find this?
Sorry, I have a question.
Mm-hmm.
I guess I missed the beginning. Like, what data did you put in order to compute?
You just go to stats.
No, I mean before that.
You go to your data called earthquake.
Okay.
You click on it and they will automatically import it over here.
You know how we fill in numbers?
No.
So no filling numbers.
If the question gives you numbers, you have to fill it in.
Right.
If a question call you to get it from the data list,
Okay,
you
gotcha.
don't. Do you want to fill in 600 numbers?
No.
Okay, there you go. This
Okay.
is big numbers. These are 600 numbers here. So I will call you to go to the earthquake to get it there.
Okay.
Now the question in the next question is asking is, so this is if San Francisco Bay was struck by an earthquake that's measured 7.0. If we added 7.0 into this data set, do the measure of variation change much? So what I did here is this is no 7.0. This is just 600 from the data set. So what do I do in this case? Let me just get rid of this fellow here. So I'm going to scroll all the way down to the end of the data set. And that's 600 of them. And yes, you do not want to enter it. So this is magnitude. So I'm enter one more number, and that number is 7.0. So I just put 7.0 and enter. So this is the 7.0 earthquake that is measured, and I put it in extra. So now I'm going to redo the variation again. So I just click again, stats, summary stats, column. magnitude, and then Control A, and then compute. So now your number changed, right? Because I have this 7.0 in there. So if you look at this result, the 7.0, can you tell me what is your range in this case? It will become 5.91.
5.91,
And what is the standard deviation in this case?
0.67,
0.67. And what is your variance? I mean, I'll go a little bit so you can see it. What is your variance in this case?
0.46.
0.46. And then the IQR?
The IQR is 0.89.
So the reason why I bring this one up to you guys is I want you to compare. This has no outliers because we know 7.0 is an outlier, right? Because they are really common. And the other one has an outliers. So the 7.0 is included. So can you tell me which one of these changes the most? The range, the standard deviation, the variance, and the IQ or the IQR. Which one of these changes the most?
The range.
Okay, so you notice that the range changes the most with an outlier. Okay. Lawrence, I'm going to mute you. Yep, thank you. So range is, in this case, out of these 4, range changes the most with an outlier. Now, this is only have one outlier, and you can tell out of 600 numbers, only one outliers, your range changed the most. But if there are multiple outliers, that means now I put like a few more 7.0s. So what happens if I put a few more 7.0s? This is something that I want you guys to know. So I put another 7, another 7. I put 10 more 7s. Okay, I put 10 more 7s here. Okay, so what happens to my result if I have 10 outliers? Not 1, but 10. Let's see how much difference does it change. My range is still 5.91. So this one I put 10 outliers, right? I got 10 of them. My range is still 5.91. Standard deviation is what now? Let me move that around. 0.86. Variance is 0.73. And IQR is still 0.9. So if you look at this, if you have a lot more multiple outliers, which one is the least changes? Which one of these changes the least?
The range?
No, the least, the not the most, changes very little. The range,
IQR.
the IQR. I mean, if you compare the no outliers with 10 out, compare the no outliers. So you find out that the IQR only changes a little bit, right? So this is something I want to point out to you here. If there are multiple outliers, the IQR will change the least, change very little because it is not affected by outliers. So this is the
hello. Was that why you said it has a resistance to outliers?
Yes.
Thank you.
That's why I'm showing you what's going on here is because IQR is resistant to is more resistant to outliers compared to range and saturation and variance. The IQR has the most one. So that means that it's not affected by outliers. So this is something I'm showing you in the data set so you know what's going on. So this is just to support what I'm trying to tell you here, that the interquartile range is resistant to outliers, but the rest of them do affect by outliers. Okay. The most dramatically affected is the range. You can tell the range is, but the standard deviation and variance do changes, but the IQR is the least one, the one that changed very little. You guys got what I'm trying to tell you here? Because you need to know this, and now you see it on, on the data set why IQR is better if you have outliers. Anyone have any questions for me here? Okay, this is the end of today's class. We will continue on Wednesday about the empirical rule and the compare. Yeah, we're gonna finish this 3.2. We still have a little bit left. We still have the question 3 and question 4 left, and then we'll start 3.3 on Wednesday in class. So make sure you guys come to class on Wednesday. If you have no questions, you may go, but if you have any questions, please stay back and ask me. So don't forget your homework due on Wednesday. This coming Wednesday will be 2.3 and 3.1. Okay, 2 sections due on this coming Wednesday, and then 2 more sections due on the following Wednesday, 3.2 and 3.3. So anyone has any questions for me? Stop recording here.